So today we are going to talk about subatomic particles. Okay, so today your topic is subatomic particles. Your goal, I can list and find the number of subatomic particles of elements. First, matter is anything that has mass and takes up space, like volume. Some examples: a brick has mass and takes up space. A desk has mass and takes up space. A pencil has mass and takes up space. Air has mass and takes up space. And all of those examples are considered matter because, you guessed it, they have mass and take up space. Of course, you could think of all sorts of stuff that is matter, but is there anything that you could think of that's not? Well, some examples are like forms of energy, like electricity. Electricity travels through things that has mass and takes up space, but electricity itself does not. So the majority of things do, even things you don't necessarily see, like air, for example. Air is there. We know it's there. That's why we're alive. We're breathing because of the oxygen. So just because you can't see it doesn't mean it's not matter, but there are things in the world that does not matter. Now, or they matter, they're just not considered matter. So in your notes section, you need to make sure to write out matter. And also what's underlined, you will need to highlight the word matter. Okay, atoms. They are the smallest possible unit into which matter can be divided while still maintaining its individual properties. Okay, it's made up of protons, neutrons, and electrons. We're going to talk about what each of those three things are separately. Okay, the solar system is commonly used as an analogy to describe the structure of an atom. Now, almost everything we talk about in chemistry stems from atoms. What atoms are made up of, how atoms react, what they do, what's going on. It stems from the atom. So you do need to make sure you know what an atom is and what it means. So you need to make sure to write and highlight the word atom, and then also type out the definition, everything that is underlined in this slide. So, example of protons, they are in the nucleus. Neutrons are also in the nucleus, and electrons are outside. But again, I'm going to go through and explain what each of those mean throughout this slide. Okay, so first, protons. They are in the nucleus. They are positively charged particles. They help make up the nucleus of the atom. They help identify the atom, could be considered an atom's DNA. They are equal to the atomic number of the atom, and they contribute to the atomic mass. They are also equal to the number of electrons. So go ahead, take a moment, pause this video, type out this stuff. You do need everything that's on the slide. Everything is underlined, and make sure you highlight the word proton. Neutrons. Neutral particles, they have no charge. They are not positive, they are not negative. And they help make up the nucleus of the atom. And they also contribute to the atomic mass. So go ahead and pause this, make sure you write those three things, or type those three things, and highlight the word neutron. Electrons. They are negatively charged particles. They are found outside the nucleus of the atom, and we'll talk about where at outside the nucleus in different orbitals and levels later on in this unit. They move so rapidly around the nucleus that they create something called an electron cloud. The mass is insignificant when compared to protons and neutrons because they are way smaller than the protons and neutrons. They are equal to the number of protons, and they are involved in the formation of chemical bonds. Okay, so again, pause on this slide. There's a lot you need to type out. You need to make sure you highlight the word electrons and type out everything that is underlined. All right, how to tell elements apart. Every element has a specific number of protons and neutrons. You need to write that down. Every element has a specific number of protons and neutrons. If the number of protons and neutrons change, then you're talking about a different element. So for example, helium has 2 protons. If you add 1 more proton, you no longer have helium. You have something called lithium. So how do we know what an atom is? Well, if you go back to our history of the atom, you'll notice that there were several steps and experiments, and it took a lot of time and a lot of work, and we realized what an atom is and how they react. Okay, one thing you may not have heard before is something called a quark. They are particles that make up protons and neutrons. So yes, there are in fact things that are smaller than protons, neutrons, and electrons, and they are called quarks, and they make up protons and neutrons. Notice the smaller particles that make up this neutron after you take a closer look. There are 2 of one kind, 2 that are orange, and 1 that's blue. And on the other one, there is 2 that's blue and 1 that's orange. So what do you notice about the number of quarks in the neutron and proton? There are 3 of them. And the quarks is what causes it to either be neutral or for it to be positive. So make sure you write and highlight quarks and that you put the definition for quarks. Next, atomic number. That is the number of protons in the nucleus of an atom. So what would be the atomic number of this atom? If you look at it, here, go back. Pointer. So protons are positive, P, proton, P, positive. You have 1, 2, 3 protons. So the atomic number of this would be 3. So make sure you have this stuff on this slide that's underlined and highlighted. The mass number. That is the total number of protons and neutrons in the atom's nucleus. It's expressed in a unit called AMU, which stands for atomic mass units. Each proton or neutron has a mass of 1 AMU. So here, your mass is your protons plus your neutrons. So if we look at this, we have 1, 2, 3 protons. So that's the atomic number that we talked about the last slide. But now we also need to add the neutrons. So 3, 4, 5, 6, 7. So this atom has a mass of 7. Okay, so make sure you have what's highlighted and underlined on this slide. Now, here's a hint. Why do we not account for electrons when calculating the mass number? That is because they are so small and so light. They do not have any significant change to the mass. So the mass only makes it, the only thing that really affects the mass is the protons and the neutrons. All right, so let's identify. You will need this for one of your slides. So if you go to the next slide and you can't remember how to identify, come back to this part of the video and it's labeled for you. So the atomic number is the whole number and it is the smaller number. So atomic number, smaller number. The atomic mass is the bigger number. Now, there is A way to remember this, everyone wants a big mass. Everyone wants a big mass. So just remember, the big number is the mass number. The number of protons is the same thing as the atomic number, so it's this smaller number, this whole number. Number of electrons is also this number, so this 6 is your atomic number, your number of protons, and your number of electrons. Okay, now to find neutrons, you take the big number and subtract it by the small number. So if we were to round this, like round 12.011 to 12, it would be 12 minus 6, which is 6. Now if you look at sodium, the atomic number for sodium would be 11. The atomic mass would be 22.990. The number of protons would be 11. The number of electrons would be 11. The number of neutrons, so let's round this 22.99, rounds up to 3. So 23 minus 11 is 12. So you would have 12 neutrons.